Welcome to the Senior Physicist Group meeting talk. Today is the first day that we're broadcasting from the physics department at the University of Maryland. And for making this available, I'd like to thank both the University of Maryland Physics Department and Professor Ralston, who also participated in making this possible. And also I'd like to thank Ted Einstein, who contacted people. Okay, a word about the Senior Physicist Group. It's entirely voluntarily, and we schedule our talks on the third Wednesday of the month. At least that is our preferred date, although it's very flexible, bending to the speaker's calendar. And we have a planning meeting on the first Thursday of the month. Both of our meetings start at 1 o'clock. In August, we try and schedule a tour of a physics site or one of scientific interest. But to date, we have no tour scheduled. But if we can find a place to go, we will schedule it. One thing that I skipped over is that in July, we have no meeting and no planning meeting, no talk and no planning meeting. Okay, with that, let me introduce our speaker. Our speaker today is Michael Brabanski, and his dossier, Mike received his Bachelor of Science in Physics and Bachelor of Science in Mathematics in 1973 from the American University, and his Master of Science in Applied Mathematics in 1976 from American University. After that, he worked for 26 years at the Math Lab in the David Taylor Model Basin, which is located in Maryland on the northwest side of Washington, D.C. His talk is about the Telegrafenberg Science Park near Potsdam, Germany. Apart from its intrinsic interest as a 19th century research facility, it eventually housed several institutes. It had a solar observatory built in the 1920s to test Albert Einstein's theory of general relativity, and it is associated with Albert Michelson's first attempt in 1881 to find and measure the Earth's movement in the relative to the luminiferous ether, which at that time was believed to be necessary to transmit electromagnetic radiation. In pursuing that, I'm going to add a note of my own. In pursuing that, Michelson eventually developed a new interferometer, whose design is in use now in the Liga and used for the measurement of gravitational waves. Okay, with that, let me introduce Mike.
So I kind of volunteered myself to give a little, and I emphasize the word informal or impromptu talk about this Einstein science campus they have near Potsdam. Figuring that if things go south and something doesn't happen, it's no great loss, and if things work out fine, which they have, it might still be an interesting talk, because I suspect a lot of people aren't aware of this place and some of the history connected with it. So, you can think of it a little informal talk. Okay. Now, I originally was born in Germany, in West Berlin. We immigrated in the mid-50s, so I basically grew up in this country. I still have two cousins in now Berlin. It's no longer West and East. And after the wall fell and everything, I sort of spent a lot of my vacation times in the succeeding years in the 90s and the early 2000s, sort of reconnecting with people and my family and
Can
people
you
we know
share
and believe,
each slide on
Um,
the Zoom
and
screen?
just getting to know the city a little bit. One of the days, it was like, yes,
Sorry.
somebody's not hearing. Hey, can you hear me? Okay, good. So one day, somebody said, I think it was my cousin, she said, you know, you ought to go up to this place near Potsdam and so forth. You might find that interesting. So at that time, I first just took the light rail from downtown Berlin, where I was staying, to Potsdam and walked up there. It's about a 20-minute, half an hour walk, depending on how fast you can go. And I was surprised at this. I had never heard of this place. Okay. It's basically a large campus of about 16 hectares, which was originally started in the middle of the sort of in the 1870s. And how do I start? This got started. Okay, to understand how this whole thing got started, and you have to go back to 1859, when Gustav Kirchhoff and Robert Bunsen, the chemist from Bunsen burner fame, you know, from our chemistry lab days, they first evidently put some element or some chemical into the Bunsen flame and put it through a spectrograph and found that there were these lines. And by golly, each line and the set of lines was, of course, unique to each chemical element or sort of chemical compound. And through the 60s, they began developing this. And this was a revolution both in chemistry, because you can now do an analysis. You can just stick your little piece of material, what you had in there, make a spectrogram and check the lines against some standard book or something, and you know what sort of elements were in there. But especially for the astronomers, this was a revolution. For all of human history up to that point, the only thing astronomers could do was look up at the sky and maybe do positional studies or make notes of some maybe strange phenomenon, a light going up or a comet coming by. Not to knock it, the attempts to, of course, get a model for the positions of and the movement of the planets eventually led to Copernicus and Kepler, and of course Newton came up with his gravitational theory, explaining why the planets move in ellipses and so forth. So this was a major step. But other than that, astronomers, you know, really couldn't do any more than that, except make star charts and kind of keep watching the heavens. Now they had the ability, if they could get a spectrum of either the sun or a star, they could figure out what elements were in there, what the hell was in there. And in fact, the element of helium, I believe, was discovered first because they found these lines when they did a spectrum of the sun. They found these lines which they didn't recognize in any other element, and called it after, and they named it after the sun, sort of Helios, and we have helium. And it was sometime later that chemists down here on Earth managed to isolate it and find it was a gas, a sort of a noble gas. So we're talking about through the 1860s, this was developed. And by the end of the 1860s, the astronomers were wanting to get serious about this. And they realized to set up observatories with spectrographs and everything, they really had to they had to set up and build some brand new observatories. And if I can get
We cannot see the slides.
maybe get a picture.
Right.
What?
They could not see the slides. That's because they haven't been opened yet.
Okay, they couldn't see something?
Don't worry. Just keep
Okay,
going.
if I can find this, I think here. Let me just. Can we get the picture?
Double click it. double click that icon.
Can we click on the picture here?
Yep, double click on it.
I,
No.
that's
You
what-
want that one open, which, one?
Yeah, so let's try.
This one. Or- Okay, open with, I can't read it. Open.
Okay,
Okay. This is a painting from the 1830s. This is downtown, Old Town Berlin. The street here is, I think, is Dorothean Street, which is a couple blocks off of Unter den Linden, which is the main drag in the old part of the city, okay? What you're seeing here, the building with the mast on top, is the old Berlin Observatory, which dates back to the year 1711. Okay, if we can. Well, here, if we, I'm not sure if you can.
That, that's
Yeah,
not gonna
okay,
show
okay.
up, except, I mean, it'll show up as a blur.
Okay.
If you want.
Most observatories in Europe at that time were built maybe in the 17th century, so shall we say, when even cities, when the sun went down, you did not have even gaslight yet. It may be a candle or two in windows, so it was actually very dark. You did not have light pollution problems in those days. But by the mid-19th century, this was all changing very rapidly. Like I said, gaslight was coming in, eventually electric light, and Berlin, in the wake of the Franco-Prussian War and the first sort of unification in 1871, was about to just explode and burst at the seams as it became the center of government and commerce and science and the whole bit. So they had to they couldn't use these observatories. The observatory itself would move to other parts of just outside of Berlin, and then he finally itself moved to Potsdam. But the astrophysicists, that is to say, the people who were interested in using spectroscopy, which today we would call astrophysicists as opposed to straight astronomers, they needed to have a place which was quiet, because these spectrographs were very sensitive. We have no light pollution and no smoke from burning coal, which they did, et cetera, et cetera. And so they were now looking for some place to build this. So I think the original idea was to attach it to that, but they soon to this observatory, but they soon found that was just it would not work, and so they were looking completely outside Berlin, and what they picked was, and unfortunately, I couldn't find a map. I mean, I tried getting Google Maps, but I couldn't get a picture of it. So, if you let me get this. Now, I would say also remember that mass which you're saying that will pop up in a minute too, as a sort of a footnote. So let me see if I can get a picture here. Now, let me bring this up. Let me bring this up first.
Okay, right click it.
Yeah, what? The right or the left one?
The right, where are you? Which one you want?
Okay, I may be clicking on the wrong one.
Well, I don't know, this will work. Oops. Copy here. No.
I tell you, Ubuntu is much better than this.
If you put it in PowerPoint, it works fine.
just don't click it into that.
Where? I don't know why it's not opening.
Okay, can we get this a little bit larger? that this is. Yeah, the point is, can we,
can't get it.
you,
Not now. I don't know how to do that.
okay.
Follow that one can, but I
Can
can't.
you get hook onto the corner and possibly?
Stretch it?
Yes, here we go, here we go,
Okay.
thank you. Okay, this is, just to show you the area around Berlin and Potsdam. They picked a place,
Can you share your
A-
screen?
a wooded
Can you
hill
share-
where.
Can you share
who's
the
just to
screen?
the- Yes.
If you,
You have a question?
can you share the screen so we can see the slides?
The screen is being shared.
No, it's not. Maybe you're on two monitors. The
Yes,
thing
you're
that's
on,
being shared is your directory with the figures.
How did it get back?
yes,
to
that's
the-
correct. The wrong monitor is being shared.
Okay, fine. I need to get back to not having.
We
this
can see your desktop.
I understand. I'm getting there. I don't
All
know.
right, good.
It says I am screen sharing. Can you see this page now? Hello?
No, all we're still seeing is your directory. It's again
right.
still.
Yeah, I
kind of-
know. It's just
yeah.
directory now, but you can see the directory.
We've
Yes, we can see the
always been
directory.
able to.
Okay, can you see this now? Because it says I'm screen sharing.
No. We can only see the directory.
It doesn't make any sense.
This is why I don't use Windows.
Yeah, well, this is why we're here.
If we had it in a PowerPoint talk, like everybody who
Okay.
gives Windows talks, it would work.
Yeah, but yeah, I can click on a picture and it comes up like that.
Bring
Okay.
your
Yeah,
laptop.
yeah, okay. So,
I'd never worked with Ubuntu before. I guess I have to call her.
okay. So can we,
Sometimes you have to exit and come back in again, and that because it is tricky sometimes to say you want to share which
Well, I have-
monitor.
Oh, so I should stop share and start share again?
That
Yes.
that
I
might be
stopped
it.
share now, and I will try restarting share.
And it may give you an option of to which window to.
Right, it does.
And so if you remember the old one, use whatever the other one is.
no,
How's that?
Oh, yes, perfect.
Okay, thank you for the suggestion.
Got it, well done.
Good.
okay, so we can see everything? All right.
Physics is an experimental science.
Yes, yes. This is, like I said, it's partly a talk on the history of this place and partly a bit of a travel log. This is typical of the area around Berlin, Potsdam. Basically from Holland through northern Germany, Denmark into northern Poland, what was formerly East Prussia, the Baltic states. It's just sand left over from the last ice age, okay? Occasionally you will see, it's flat as a pancake, okay? Occasionally you will see sort of a light rise, and these are basically sand hills. They're basically a moraine which were dumped by the retreating glaciers at the end of the last ice age, okay? So this is typical of the sort of scenery. This is from a height, from a building near Potsdam, and I made this back in the early 2000s. and just with my little camera for aficionados of the Cold War, especially spy stories. If you look at the bridge that's there in the middle of the yeah, here.
There?
Here, yeah. There's a suspension
No,
bridge
no.
right here. Yeah, thank you. The river is the Havel River, which goes down Berlin's western side and then turns, I guess, west, eventually getting into the Elbe River. That is the Glienecker Bridge. This is where Gary Powers and other spies were exchanged back in the Cold War days. This side here, this area here, is part of Berlin, or back in the Cold War days, West Berlin. This side here is Potsdam, or I guess was part of East Germany. Okay, and that's where they always did these exchanges. You're always seeing spy movies or whatever. All right. Okay, so we're gonna go to. Let me. Sorry. Hold on. Let me go to the next one. Next time I do this, I definitely need to start using the PowerPoint I have on Ubuntu. And okay, can I get rid of this? There's an and just take the next one.
If you go back to that page, it's further through. Oops.
Nope.
Let me get to Kim's screen. Screen sharing has stopped. Okay, we'll start sharing it again. Find the picture you want.
Okay. Let me just do a quick one. This one. Right click.
No, try right click and then open up here, the first thing.
Open. Right click.
Left click.
No, left click then. Okay.
Okay, now I need to
okay.
share again.
Oh, you can't share it?
It's somehow unshared. I don't know why it unshared. Can people hear anything now?
I can hear.
Okay, so we still must be in Zoom.
Yeah, Zoom is working.
Yeah,
I can see Michael. I can see 15 people.
right, but I don't see my share anymore. Where the hell is?
Double click it.
Yeah.
Oh, let's see, if you click on share.
Yeah, I tried clicking
they-
on share.
Well, you selected, okay, and if you click on share, it may be on the whole screen.
Okay, now it's gone. What the? Edit. This is what you want?
No, I wanted, there was another picture of downtown Potsdam, which I just want to bring up for a second,
Which is,
and then go on to the third picture, which actually shows,
okay, here we have downtown Potsdam. Everybody can see that?
I can see a building
Yeah, with a green
with a couple
dome.
windows and some frames.
yeah, that's a church, that's an old church. Okay, can we, okay, does everybody see this? This is, okay, this is just a bit of a travelogue. This is downtown Potsdam. There's a few buildings. Can we, this is a church dating back, I think, the 18th century, and a few buildings. The building up in front here, and there's another one right here in the back, which I think was actually a stables at that time, although now it's an art space or something. Some of the modern buildings, I think, got replaced because of, you know, the destruction in World War II. So I bring this up because you'll see the domes and everything in the next picture. So like I said, I'm trying to throw in a bit of travelogue here, which you might find interesting. Okay, so can we bring up the third one? Which would be that one right here. And that would show the. Okay. Now, you know, this is the same, the direction, you'll see basically downtown Potsdam, the church and a few other buildings sticking out. But if you look in the background, yeah. Hold on, sorry. There's this sort of low hill coming up. That is the hill on which they were going to be, on which they'll build all of this. You can just see a sort of dome sticking out here, lightly colored.
We're not seeing
is
that
the
slide.
dome of the large refractor.
Still on the last slide.
Okay, can you hear me? Yeah.
We
And
can hear
the
you,
building
but the
sticking out
slide
here-
has not changed.
We're still on the last slide. The new slide didn't come up yet.
I still see
wonder-
that building.
Right. I wonder if in this image showing thing, I noticed that there, when your mouse goes up to the side, there are arrows. So it could be if you just stay within this window, you know, move the mouse up to that other monitor in the image viewer on the right, there's like a little arrow that will advance you to the next image. That might.
There's only one image here. You want me to go back to the,
Well, I'm wondering if usually these things have a way you can kind of advance to images within that same directory.
Yeah,
by-
these are brochures about it, and those are the ones I'm, especially this one here.
do you have any
They have
idea what
several-
I should
They
click?
have a number of historical essays on all this place. But of course, it's in German, so it's not going to be, it's not something most people would know about.
If the mouse
So,
can go up into the
and
big
then also,
screen,
what was the architect?
then
who
it's possible
wrote
the
this?
arrow, when you then move to the black on the right or on the left, there'll be an arrow that can advance you or not. It's possible.
Oh, I don't see anything like that.
What?
The interferometer there, is that the same design they used in
What?
the interferometer?
Yes, that's something I'm going to bring up in a minute.
And that's the same design that they.
Yes,
used for
that is a reproduction of his 1881.
Okay, is that the same one they used later when they
Yeah.
determined that there was no leak there?
Yeah, well, he used that in his 1881 attempt. He made two attempts, in 81 and in 87 with Morley, or at least there were two papers. There was an 81 paper.
That same interferometer used in 87?
No, that was the one he used in 81.
Okay, how was the one in 87 changed?
I don't really care about that because he did that here in the States.
Okay,
The 81 he did in Germany, in Potsdam, and that's what I'm trying to.
Okay, yeah,
Okay, that's what I'm trying to bring out.
This is what we want? Is that the slide you
Yeah,
want?
okay, fine, okay,
Yeah.
all right. So here again, this is basically this hill, geologically speaking.
Excuse me, we're seeing the
already
directory again,
extends
not the
such low
slide.
hills.
Hang on.
What?
We're seeing the directory again, not the slide.
How about that?
I think that's it.
That- The other option may be that on the keyboard, again, when you're in an image editor like this, it could, oh, look, there's the, oh, there's the
an
little,
arrow.
there's the arrow
There's
that
the-
would
click
advance,
next.
and that would
Okay, this
advance.
is-
It may not be the one he wants because it will go in order of the directory, but
Well,
that
it
would
looks
be
like
the
a
way to go.
stamp.
Go back to the left side and click.
Hello.
Okay,
Yeah, where do you want to go?
so shall I continue or?
Yeah.
Oh, okay, I'm sorry. This is part of a, fine. Oh, there. Good. That's right. Hold on. Let me sit down. I can sit on both of them. Yeah, because you're gonna be seeing this anyway. Like I said, the hill is part of geologically speaking, a chain of moraine hills about 20 kilometers long in that area, which geologists have determined was basically dumped there at the end of the last ice age. So, I mean, it's an interesting factoid. This hill was originally wooded. It didn't really have a name. It wasn't anything until about 1832 or something like that, when Prussia built a semaphore telegraph from Berlin to Koblenz, Germany, and from Koblenz up to Cologne. So the clear across Germany had something like 60 or whatever stations. And if you let me show the next picture, can we?
Yeah, well, the next picture is a stamp, so I don't know. Let me
Okay,
keep
fine, and let's see if we can just expand it. Okay, this is a West German postage stamp from, I think, 1983, and you see there's a church with a steeple and with this post on top with these 6 veins. So this was the semaphore, a Napoleonic era semaphore telegraph. Okay. I think this is an old print or something. They're still spelling Koblenz with the old spelling with a C instead of a K. Okay, from 1833. With 2 Prussian officers there, sort of looking seriously and sort of discussing it. It was actually run by the Prussian army. It was not yet a commercial site because they wanted to make a connection with the Prussians holding in the Rhineland, which they obtained after the Treaty of Vienna in 1815. Let's go for the next one. I've got a better picture of a typical house. Okay, this is a typical station house. This is near Cologne, which is still left of, and you can see the veins of the semaphore. The first station was actually at the Berlin Observatory, which was that painting I showed you way at the beginning. And the station on the telegraph on that hill was the 4th station in the line. And the locals started calling it the Telegraph Hill or Telegrafenberg. That's how it got its name. Okay. The semaphore telegraph was replaced by an electric Morse telegraph in the 1840s, and I think 1849, but the hill maintained its name and so forth. Okay, so we're now moving just as a minor historical note here. Yeah, here, this is the Berlin Observatory, and you can see the first mast up there with the 6 semaphores. Yeah, so let me see. Okay, let's leave it here now. So here was this hill somewhere squeezed in between downtown Potsdam and the city of Berlin. The problem was now they had to get the money to build this observatory. And the way you do this, of course, is you try to find a prominent politician to support you. And they went, as it turns out, they got lucky and they ran right to the top. They got there was a professor of physics and mathematics at the University of Berlin who was the tutor in those subjects to the Prussian Crown Prince, nonetheless. And he was very much, he talked to him and got him interested in this. He was very much an open-minded guy. He married one of the daughters of Queen Victoria, and he supported this. And in the early 1870s, the ball began to get rolling. So you got various, the head of the Berlin observatory, a guy named Wilhelm Forster, had signed off on this. He came up with a white paper and supported this. The Prussian Academy of the Sciences did the same. And I think somewhere in the mid-1870s, the Prussian Parliament signed up on the money. And by 1870, I think 6, they were starting to build it. And by 1878, the basic building, which is what you see in the center, had been finished. Okay. And it consisted of a central dome, 2 side domes, and sort of a tower. The piece out in front here, are we seeing this?
What do you want?
Yeah, here. I think was sort of staff offices and labs. The main dome was a 12-inch, 30-something centimeter refractor. And I think one of the side domes here, I think, had an 8-inch. And in particular, and this is what we're getting at, this dome had also a telescope with a spectrograph on it. And this was now the whole point. This was not just built to be the next best observatory, you know. It was built specifically to do spectroscopic work in this new science of spectroscopic astronomy. Or what we're now, this was the beginning of astrophysics. The building in the back was the director's house, which got built a little later in the 1890s, and I'll talk to that in a minute. I'll mention that. Let me see.
Next slide.
Okay. Yeah, this is just another.
Do you want it?
Yeah, make it a little bit larger. Yeah, right. This is another picture I got off the web. It basically shows the building here. If you take the next one, they've got various pictures. Here again, I'm just, this is a picture I took one day. This is, and see if we can get a next one. This is basically the travel log, so to speak. Yeah, this is the front end. The building is directly on a meridian, so which goes right through here. North is in this direction, okay? So the other views were basically from the south. This was offices and labs and photo stuff. And okay, let's try the next one. Okay, no, back off now. Let's back off for a minute and just stick with the building itself.
You want the previous
Back
one?
off, yeah. I'll talk to this a bit later. I'll just mention this briefly, some of the other buildings.
Yeah.
Back off where you see the south side and you see the actual domes. Yeah, this, maybe back off one more time. Okay, this is fine. Just bring this up. Okay. So this was around 1880. You're talking about late 1870s, around 1880. This was what was on the hill. Okay, and the people were starting to use this. So now we get to come to Michelson. He of course graduated from the Naval Observatory, from the Naval Academy, as I understand. Served as an ensign for 2 years, sailing around the Caribbean or whatever. He finally got himself transferred to the Naval Observatory. in the 1870s.
Was the Naval Academy in this country's
In
academy or
Annapolis.
in Germany?
No.
No, this
Michelson-
country's,
is it-
Michelson is a German. Michelson was American.
Right, okay.
Now, yeah,
He was, I think, the
Michelson,
first American Nobel Prize.
yeah, Michelson
I-
actually
okay.
was
Never been.
born
But-
in what was then Prussian Poland. Believe the city is Strelno or Szelno, something like that is in Polish, which was at that time part of Prussia, because Prussia had large chunks of Posen and what they call West Prussia, which later became known as the Polish corridor, quote unquote. That was all part of Prussia. His family immigrated to the US when he was like 2 in the 1850s, and he grew up here in the States. So how much German he knew or didn't know, I'm not sure. But so we're talking about, he was here at the Naval Observatory. Now, he evidently was not much interested in terms of being a naval officer. His interest lay more in science. And while he was there at the Naval Observatory, he got a leave of absence for 2 years from 1980 through 81 to go to Europe to study there as to what people were doing in optics and this new field of electromagnetics. Michelson himself, I think, had made an experiment to determine the speed of light in the 1870s when he was still at the Naval Observatory as a student, and came up with a halfway decent value, okay, believe it or not. You know, the 299, whatever kilometers per second, 1,000 kilometers per second. So given what he had, this wasn't a bad deal. But as I said, it turned out he was more interested in science, and I believe he got Alexander Graham Bell to cough up the money to support him to go over there for the 2 years. Here again, this is for me a work in progress. The more you get into this, like everything else, you know, I'm going. The more you learn, the more you need to nail down certain things. You know, I'm basically basing this on some brochures which I picked up from the when I was over there. Okay, and particular a book here called a set of almost 10 historical essays about this Telegrafenberg campus, the buildings, the people who built it, and some of the science that was done there in those days. These are excellent essays, but they're all in German. It's the Einstein term in Potsdam. The subtitle is "A Architecture in Astrophysics," and I'm Googling, you know, and the more I learn, the more I need to get into this. Okay. So you have to understand this is kind of a work in progress, which is why I want to keep this talk informal. This is as far as I've gotten in all this. Okay, so 1880, he goes to Europe. He spends half of that time going to Paris. And he studies at whatever schools, the École Polytechnique or whatever. I believe there was a guy named Arago, who was a big physicist, maybe Fresno or something. So he studies with the French for 2 years. Then he goes to Germany, spends some time at the University of Heidelberg. And I don't know exactly how much, I think it's roughly 50-50. And then he goes to the University of Berlin, which is downtown. It's not far from that picture I showed you of the Berlin, that old painting of the Berlin Observatory. The university is basically downtown on den Linden and the surrounding cities, surrounding streets. So, which is important. It's basically downtown, and in there is specifically a physical institute, translated literally from the German, which was within the university or somehow directly connected with it.
Wow.
Which was set up by Hermann von
Really a
Helmholtz.
flood.
Okay, he's running this. Helmholtz was very interested in this. Yes, you have a question?
Come on. Come on.
I'm afraid that Ted has muted himself.
The speaker seems to be muted.
Can't hear you, Mike.
Ed, can you unmute? We're not getting any audio.
Institution, you don't sit around and sort of twiddle your thumb and listen to talks, but you maybe work on a little project or something like this to have you work it. Perhaps you yourself, once you would like to get, if you're a professor, to some little project you wanted to do, which you haven't had time to do it, because teaching or whatever. So this is a good time to do it. So somehow it came to be that Michelson should do this little project. He evidently had a design for his Michelson interferometer. Okay. And maybe we get this built and then it was believed by physicists of the 19th century that
That's right.
the electromagnetic, waves were carried by this funny substance called the ether. Right? These waves were like sound waves moving through the air were carried with this ether. And if you could measure the speed of, say, something, let's say the Earth, relative to this ether, you could figure out how fast the Earth was going. And he wanted to do that with his interferometer. Okay. So what he did was he had it built, and this is. Let me see if I can bring up a PDF here. Okay. Can we put this somewhere? We'll get back to this. No.
I can't see what's going on. Okay, so let's, we're not sharing now. I know we're not sharing. I'm trying to get to the next thing. Okay, what do you want? What do you?
Yeah. Now,
Directory again.
there's a PDF here on
This one? This one?
Yes, this is Michelson's 1881, the far left one, 1881 paper. That's a PDF. if we can
Yeah,
get-
yeah.
Okay, perfect, thank you. Back up. No, this is actually fine, I think. I think it's fine, okay. All right, great. Here, this is the start of this is a PDF of Michelson's 1881 paper, which he published back here in the States when he got back in the States.
You're still screen sharing the
in,
directory, not the paper.
You have the relative motion of the Earth. From here, the master of the U.S. Navy or something. He goes through the derivation, and let me see if we can we go down a page or two.
We're not seeing the
Okay.
paper, we're seeing the directory.
Again,
You need to screen share the paper.
right, it says stop share.
Ken Crane, no.
Nope. Okay,
Okay, keep on going, because this is just the derivation and everything. I don't know. Okay, you see, he begins describing how this would all work with this interferometer. Okay, keep.
It's at least clear.
Okay, stop for just a second. You see, this is a top view. Okay, okay, now keep going. He's got another. Okay, stop. Okay.
Oh, good.
Okay, now stop for a second. This is sort of a side view of his interferometer, which, all right. Now, let me, okay, so he has his interferometer, and the first thing I'm going to say, and he says exactly what he was doing here. If you go look to the second paragraph there, the apparatus, as above described, which was all the stuff in front, was constructed by a Schmidt and Hensch of Berlin. Michelson himself did not build it, nor did the University of Berlin, nor did some sort of a mechanic or optician at the university or maybe the institute there, the physics institute, build it, which you normally would think, because often these places have their own mechanics, to build lab equipment and stuff like this. Rather, they went to a private little company called Schmidt and Hensch, which was founded by two guys in the 1860s. They were mechanics, and I think one was an optician or something. If you were to Google that, which I did, that company still exists and still exists in Berlin, and they still make sort of lab equipment and testing for industrial and testing equipment for industrial purpose. It's like 160 years old.
wow.
A family. This is typical of a lot of German companies. They, got started in the heydays of the 19th century as startups, as we would call it today, and somehow managed to survive by the years, and are still a going concern. So here again, as an interesting historical footnote, Michelson himself did not build it; he contracted out for it. I guess using some of Graham's funds, which he got to pay for this. Okay, now we get down to he wants to play with this and start seeing fate. He wants to see the fringes shift around, and from that determine the speed of the Earth relative to the ether. Next sentence. If the interferometer was placed on a stone pier in the Physical Institute, Berlin. So here he is downtown at this institute or the university. Somewhere they have these built rooms, where they have the labs and the offices. Somewhere I guess they put a pier, I guess maybe in the first floor of the basement or something. Here again, you want a stone pier because you want this to be solid. You don't want it to move with a creaky floor or whatever. Okay, so he sets it up there, and I don't know exactly where the building may not even be there. Okay, now, the first observation showed, however, that owing to the extreme sensitiveness of the instrument to vibrations, the work could not be carried on during the day. So evidently, now Berlin it's not exactly that we had, 18-wheelers rolling down the streets of Berlin in those days, but there was enough commotion or whatever, temperature changes, who knows, that he could not get the fringes to really work by. The experiment was next tried at night, thinking things would quiet down then. When mirrors were placed halfway on the arms, the fringes were visible, but their position could not be measured till after 12 o'clock, I guess at midnight, and then only at intervals. When the mirrors were moved out to the ends of the arms, the fringes were only occasionally visible. So he was having trouble getting anything. And like a good experimentalist, he tried to isolate other effects that were screwing with effects he was trying to get. Michelson, as you might know, he had his issues with relativity. He was still very much a 19th century physicist, but he was a real crackerjack experimentalist. And he went after, like any good experimentalist, after effects which would interfere with the phenomenon he was after, like a hawk. And that persisted through all of his experiments down to his 1887 experiments with Morley, the other experiments over the year, and I think his final experiment to measure this in the 1920s when he tried again a few years before his passing. So I don't want to knock Michelson. He was a really good experimentalist. So here we see him trying to figure out what the hell's going on here and trying to minimize other effects. And then he says, it thus appeared that the experiments could not be performed in Berlin, that is to say in downtown Berlin, because this is, the middle of people walking back in corridors, creaky floors, whatever. And the apparatus was accordingly removed to using the German Astrophysikalisches Observatorium in Potsdam. So somehow he got some of the people there, he must have gotten contact with the astronomers, they must have known these guys and said, why don't you go up there to this little hill outside of Potsdam? It's a quiet place, similar to your problems when the people who are using the spectrographs would like that place because it's quiet and you don't have as much disturbances. So this is probably just the place you want to try it. Okay, so somehow he must have, I guess in those days, by horse-drawn carriage or something. He gets there. No, come back.
Oh, all right.
Yeah, come back. Yeah, and we will get to this in a minute.
Where are we?
No, here, the Michelson 81. Yeah, I just want to finish off the.
Yeah, no, I was just
yeah.
trying to rotate you in, and I don't know why it popped off.
Okay. Even here, the ordinary stone piers did not suffice. And the apparatus was again deployed. So I imagine he must have tried something on one of the rooms on the ground floor or something like this. He doesn't, he's not quite precise. Then he says, and the apparatus was again transferred, this time to a cellar whose circular walls, pay attention to that, formed the foundation for the pier of the equatorial. And the equatorial here is one of the telescopes. And remember that, I'll go back to the other picture in a minute. But here the fringes under ordinary circumstances were sufficiently quiet to measure, but so extraordinarily sensitive was the instrument that the stamping of the pavement about 100 meters from the observatory made the finish disappear entirely, exclamation point. So this was really, if this was the case with the instrument constructed with a view to avoid sensitiveness, what may we not expect from one made as sensitive as possible? At this time of year, in April, which I guess was 1881, and he goes into detail. So the problem was he had trouble getting something. If you maybe go down a little bit. Okay, hold on. And then near the two components, like, yeah, he tries various things, and I don't want to get into the principal difficulty which was to be feared in making experiments was that arising from changes of temperature of the two arms in his one. So he has all sorts of issues here, and I don't want to get into the details. And I think the bottom line was, if you go to the last page, I think he says, right, then he gives you all sorts of, okay, stops. Okay, I had long, okay, I had long been desirous of trying this experiment with a large aperture and made several attempts in 1874 to have the dome of the 26-inch reform refractor at Washington, that's the Naval Observatory. Stop, okay. To have that terrestrial object to be seen, but without success. I therefore took the first, and then he mentions other ways of doing it. So he evidently has been thinking about this for some time, and he mentions also here, in conclusion, there was the one quite next to the last paragraph up here. In conclusion, I take this opportunity to thank Minister A. Graham Bell, who has provided the means for carrying out this work, money, and Professor Fogel, the director of the Astrophysical Observatory, for his courtesy in placing his resource at his disposal. So the bottom line was he tried a number of things, had a great difficulty doing this. I think at the very bottom he mentions.
This is it.
Yeah, I think he just mentions. I'm not sure this is the bottom, or if not.
That's the end of.
Okay,
file.
then go up a little bit. Sorry. Yeah, I think here it says, he says the interpretation of these results is that there is no displacement of the interference bands. The result of the hypothesis of a stationary ether is thus shown to be incorrect. And the necessary conclusion follows that the hypothesis is erroneous. This conclusion directly contradicts the explanation of the phenomenon of aberration, which I guess people were trying to, which has been hitherto generally accepted and which presupposes that the Earth moves through the ether, the latter remaining at rest. Whoa, I think we're getting now. Yes, okay. So he has great difficulty. As best as he can make it out, he cannot find the effect which he's looking for. And okay, and his time now in Europe and Germany is over. He goes back to the States, he writes this up and submits it to the journal, okay? As best as can be tell, like he says, as he points here, there's something funny with this assumption of the stationary ether. Now, people don't pay much attention to this. He himself, being a good experimentalist, I mean, at this point, he left the Navy and took up a position in Cleveland with a university.
Case Western Reserve. It was Case at the time.
And then he meets up with Morley, who is a chemist, and the two work out this new version where they have this block of granite on a pool of mercury, which is sort of the best that 19th century damping technology can throw in this problem, okay? And he does this.
The granite was on the mercury?
What? A pool of mercury, yes.
Yeah, but where was the granite?
The granite was sitting on the mercury, it was floating on the mercury,
Okay.
okay? And there he puts up the next version of his interferometer. And then when they try that and don't find things, they write it up and submit it. And that is now the famous 1887 paper, which most people are aware of and quote. And it is only after that in the 1890s that people, a lot of physicists, Fitzgerald and Lorenzen, Howland, and Poincaré, and I think there was some bureaucrat in Switzerland who got interested in this and began paying attention as to what the hell's going on here. But what people, the main point I'm trying to make here, people don't realize, and generally don't know, that Michelson had been thinking of this for some time, and that he actually did the first attempt in Germany, in Europe, here in the Potsdam, at this observatory there on the Telegrafenberg hill. Let me show you, and I've got some pictures here, which is what we're going to get to. If you get to it, bring up here, again, get rid of this now and bring up one of the pictures here, just one of the main buildings.
This one?
Okay. Okay. Okay, make it a little bit larger here. Okay, stop. And here again, I kind of emphasize, and I don't know about the audience, but for myself, you know, having come through the sciences and having used in science since I was, you know, a kid or teenager, and I think like all of us, we've read our share of histories of science or books, you know, or popular books of one degree or another, where they throw in some history of one sort or another. I was not aware, somewhere I picked up that there was his 1881 attempt, but I also thought he had made it here in the States. I didn't know that. And my feeling is that generally this has not really been picked up by people. And just for instance, we pick up here Kip Thorne's now famous work on black holes and on time warps from the mid-90s. And he has, in the first chapter on special relativity, he has, in the first chapter, he has a little paragraph to verify this prediction, etc. Albert Michelson, a 20-year physicist, took up the challenge in 1881 using an exquisitely accurate experimental technique, now called the Michelson interferometer, that he had invented. But try as he might, Michelson could find no evidence whatsoever for any variation of light speed with direction. The speed turned out to be the same in all directions and all seasons of the initial, in all seasons, in his initial 1881 experiment in Potsdam, Germany. And the same to much higher precision in later 1887 experiments that Michelson performed in Cleveland, Ohio. But then with the chemist Morley here. But here again, he doesn't elaborate anything. So most people reading this, they think, okay, there's this place called Potsdam, and he did something there. So I guess my point here is this is the place where he did it, and this is the context in which he did it. He had basically had a sabbatical, and he had been thinking of using his interferometer for some time, and here he got the chance to do so. So if you didn't know this before, you should be aware of this. But I've got one more picture. So the question is, where did he do this in here? He did it in this building. And I'm not totally sure here. It was either in the basement, no, bring up the, enlarge it. Okay, fine. It was either in the basement under the central dome, or I think this is the eastern dome. He mentions in the basement under the equatorial, and I don't know which. The equatorial is an equatorial mountain, which was, but I don't know exactly which dome this is. I thought I saw some reference in here, and they referred this to the eastern dome, which is on the right-hand side. But I can't swear to it, because here's what happened. In one of the trips that I was there, my cousin accompanied me, okay? We had sort of a deal, she would drive me around and I would do lunch, okay? I would pay for lunch. So we were up here looking around, and somewhere, I think I heard that it happened here, and we somewhat naively went up to this back door, knocked on the door. Lady opened it up. This is now no longer used by the astronomers today. Okay, this was like the 2000s, the early 2000s. It's used by what is now the Potsdam Institute for Climate Impact Research, which is a very famous now, rather well-known climate research institute, where they try to, run models and feel what's going to be the impact. This is a well-known institute, and it's used by officers now. And evidently she comes up and we explained to her we wanted to see where Michelson did his experiment. And she says, yes, it's down in the basement. Normally you cannot just walk up, if you're any, Tom, Dick, and Harry cannot just walk up and use it because these are offices. They do allow tours, but you have to, like for schools or something, but like you have to make arrangements, ahead. And but my cousin kind of sort of gave her the spiel, says, yes, but this is my cousin who came all the way from America, and kind of gave her a spiel, and she said, well, okay. So you go through here, and I believe it was off to the left a bit down a sort of an iron spiral staircase into the basement. And like I said, I don't remember how far we went in the basement, whether it was in the basement under the main dome or the left now, but down there, and this is what I'm going to show. Sure enough, there was, if you take the next picture, if you go down to the very bottom, it just get rid of the.
What, you don't want this?
No. They're way at the bottom. So if you try to get out of this, okay. Just go to these one here. Okay, you might as well just take the first one here. It's as good as any, and then those 3 pictures. Okay, so just kind of throw that up. Okay, all right. You enter this room, and there it is. You look at it's a round. This is a round sort of room. So we're under one of these damn domes, and there you go. You have now. This is not the original. The original interferometer, it was lost. It was last supposedly somewhere I heard seen in a storage room at the University of Berlin in the 20s or 30s. And after the war, it had disappeared. It had probably in all the, the destruction or whatever. Perhaps the Russians just grabbed it. I don't know. But in his 81 paper, he makes a good, he gives a good picture of it, which you remember. And so they're able to, they build a reconstruction of it. So this was the pier, he made the pier and he set it up in here. They have constructed, they have some posters on the wall here, we can show the other one. But this is what the original interferometer looked like. And this is what he tried down here in the basement, which was his last sort of hurrah attempt to see if he can do something. Okay.
Was it
Yeah.
made of brass?
Yeah, it looks like it's brass, yes, which is what they probably used brass or bronze. It looks like it's brass, yeah. If you go to the next one here.
Okay, the original then would have been a brass also.
Yeah, well, yeah. Okay, just bring it up here. This is the side view. You can see here they have the one on the left says the Michelson experiment of 1881 in Potsdam, which evidently tells something about how this was supposed to work. And the one on the right says it's specifically Albert Michelson, a little bit of his biography. There's a picture of him, I guess, in the 1880s or when. And the bottom right picture, I believe, is now the well-known one of him in the 1920s playing billiards, which is, I guess, a well-known picture. Okay, so here again, this is meant for when they do have tours, especially for school children, school kids, high school kids, then they have some idea of what this is all about. So here's one picture, and I have one more. Yeah, here, this is sort of a close-up in terms of, I think this is the lamp, and it goes into the beam splitter, and then you have the two mirrors, and it comes back here, and I think that this is the ocular in the back where you look forward. Okay, and this was the lamp where the light comes out. So this is sort of what I think. So here again, the emphasis I want to do, Michelson, this wasn't just his 87, which was his final attempt, or at that time. He started this, thinking about this in the 1870s, got a chance to do this when he was in Germany on a sort of sabbatical, if you will. And this is where he made the first series attempt in Potsdam. The paper, though, although it's submitted in an American journal, I think he wrote it up after he got back. So if you didn't know this, you should. This is the history of it, okay? And the larger context of this is because people were very interested in those days, on the one hand, in doing spectroscopy and getting into this new electromagnetic fields and the optics associated with it, okay? This was a hot research topic in those days. Okay, how much time do we have still left? Because
Yeah, I don't know.
It's 2:25.
it's what?
225.
Okay. I was going to talk about the Einstein Tower, but you want me to?
Well, just make it brief.
Okay.
Just talk about it.
Yeah, people can leave if they want. What do you want me to run?
Okay. Let me see if I can just go down the row here. If you maybe just quickly go down the row very quickly. Can we bring some of these pictures up?
Which one, you want the one you're pointing at now?
Yeah,
And then go across that row. Is that right?
yeah. Maybe the next one. Okay, okay, back up a little bit. Everything's,
I'm sorry, the other way.
yeah, just back up. Okay. Just to run through this very quickly. So we're talking about 1880, 81 here. In the ensuing 2 decades, okay, so Michelson at this point heads back to the States. He publishes his first paper, and so he gets together with Morley, and the rest is history. Meanwhile, back in Potsdam here, they begin adding other buildings to this, what is now becoming a research campus. They start building auxiliary buildings for staff housing. This is a magnetic this house for doing magnetic field studies. They have a special, it's a house which is built with low iron sandstone and wooden beams and so forth. Next picture, they get into, this is another magnetic field house. It's all made of wood and, wooden beams and so forth, no iron. Go to the next one. This is an auxiliary observatory. I think they have a photographic camera for doing star charts. Okay, it's sort of the equivalent of the Palomar Schmidt camera, the 48-inch Schmidt camera, which is mainly used for doing star surveys. You notice on the left-hand side, there's a mock-up of one of those semaphore poles, okay, of which the Telegrafenberg was the fourth, and you see it. This was the building when I was there was actually in a much worse shape. The dome was rusted. So this is like from, I believe, the early 2010s or something like this, where they had renovated this building and it's now being used for some other purpose. But this is sort of building. Okay, keep going. This is the meteorological building, which is off to the side. There's a tower where they have the wind velocimeters and stuff like that. Okay, keep going. This is just a tour of the place if you get in there. Yeah, this is the same one. I picked this off of Lamy and it's got all the age up on it. So this was all built in the 1880s and early 90s. Okay, next one. Okay, this is here. This is the so-called measurement meadow where they have meteorological, dew point measurement, temperature measurement. You see in the background the tower and the meteorological building. Okay. Keep going. This is the Geodesy Institute. They built another building in another part of the campus there for doing geodesy. In the mid 1900s, late 1900s, geodesy was once again a very hot topic, and try to get the shape of the Earth and various things like that. People were very much interested in. And this was a specifically institute. Go to next one, which they set up. The next picture. This is the side. The entrance is actually here. This is like the side, but this is actually where the entrance is. Okay, and then go to the next one. Okay, this is the so-called Helmert Tower. It's a telescope with the tower being protected with an outside covering. I think it was used for similar to the Naval Observatory and similar observatories to do time measurement. This was where they set their clocks by the stars, and it was also the origin for the Prussian, and then after 1871, the all-German geodetic grid. So this was sort of their center point. Helmert, it's named after a guy named Helmert, who was a leading geodesist at that time, who founded this institute and was a famous name in those days. In fact, I think somewhere at home, I stumbled being a fan of used bookstores, especially, the Montgomery County bookstores. I stumbled one day on the third volume in German of a 3-volume book he wrote on surveying and geodesy. This was like the third volume. I still have it at home somewhere. I should have brought it in. So this was a famous guy in those days. The little memorial there with the two heads, one of them is a Russian cosmonaut, one of them is an East German. This was still back in the Cold War days. I think the West Germans was it back in when we had the space shuttle. I think on one of those trips, a West German astronaut, NASA tried to bring in people from other countries, and a West German astronaut got in, and I took a trip with him one day or something like that. But the East Germans actually beat the West Germans in this case. And there was some launch where, on I guess a Soyuz capsule, or whatever they call those little basic ones, in which an East German astronaut and a Russian went up to one of the Russian space stations and did something and came back. And this is sort of, I think even before the West German guy, and this is a little memorial which still dates back to when this was all still East Germany. So one of these guys is a Russian and one of them was East German, I'm not sure which. The German, if you just bring up, okay, stop, says together on the Earth and in space. This was when East Germany was trying to emphasize its solidarity with the Soviet Union at the time and all that. So they've left the memorial there. Okay, so this is so-called Helmut Home. Okay, this went up just at the end of the 19th century. It was dedicated in 1899, and at the occasion, nonetheless, then Kaiser Willie II was there. So this is a big deal. This is a so-called großer refractor, the large refractor. It had, like I said, they wanted a larger telescope. And if you go to the next, I think when you show inside, this was right around the year 900. Okay, this is the inside. And this, I think I got off the web because it's a good photograph. This is a kind of unique telescope. It's a double refractor all wrapped up in the same outer hull. It's two telescopes in one, an 80 centimeter, which is like 31 inches objective, and a 50 centimeter, which is like 20 centimeter. Okay. It has the same kind of outer hull. And they both are sort of, as you can see, they're both controlled from the same end. Why they did that, I'm not sure, but this is a unique design, which I don't know of anything else. The carriage here on which the observer sits and in which they put instruments is always opposite, is attached to the revolving the dome, and is always opposite the dome's opening. So wherever the opening is a dome, the observer will sit, or presumably they have places to mount the instruments and so forth. Okay. If you go to the next one, here again, this is more of a travelogue, but to show you the sort of instruments they had here. This is, like I said, my cousin, who's I believe here in the middle. She before I came that year, she called up and found when they had tours, and she arranged for tours, so we went up there. And this year again, you see the ocular, where the observer would sit here. And I guess that's a guide here, a tour guide who's explaining everything to the people. If you go around, if you go to the next one. Okay, we'll get to this in a minute. Yeah, this is just another picture of the great refractor. To the extent I have time, I want to mention this one. I'll try to run this very quickly. This is referred to as the Beamten house. Beamte is a civil servant. You know, like you're in the civil service or something. Is basically housing for the staff, which was built at the same time the large refractor was built. Normally, this is of no particular interest per se, except on the roof or the tower or something like this, they had a spectrograph, a grating spectrograph, and whatever equipment they associate with this. Here again, I've never seen it, and I don't know to what extent. Keep that in mind, because we're going to do a fast forward now to, okay, this is like 1900. We've progressed 20 years from the time Michelson was there, okay? If you go to the next slide, let me see if I can. Okay, yeah, this is just a drawing. I'll stop. This is around the year 1890s or something. This is when you see in the middle, you see the original building. There is that building here. This is where the director's house is. This is where the meteorological building is. There is the, go up to that small building there. Yeah, that is the magnetic building there. We have here a little building, that is the auxiliary refractor here. We've got some auxiliary buildings here, but that is the helmet, so-called tower. Next to it there is a meridian circle astronomical building. Oh, right here. Okay, that is a meridian circle, which I did not show. And then the large building is the Geodetic Institute that goes with us. So this is around 1890 or the early 1890s. Later we would have the great refraction, the large refraction. Well, larger factor here, and then and other buildings as they come up. But okay, this is something I just found with Bev and I thought was interesting, but let's go on. Okay, stop here. This is the so-called Einstein Tower, the Einstein Tower. This is a solar observatory. It was built in the early 1920s, right after the end of World War I. And you have to go back now. Okay, if I have the time, as long as you want to just stick with me and we don't get kicked out here, I'll get back. Okay. So when I finished, it was around the year 1900. Okay, so fast forward to 1905, Einstein comes out with a special relativity, and people start obviously getting into this. The astronomers, how should I say, the astronomers, at first, you have to understand, kind of are always a bit behind. Traditionally, they were just positional astronomers. The bleeding edge in astronomers, of course, were now these new astrophysicists with the spectroscopes. In the early 1900s, 1910s, astronomy itself is trying to sort of begin to clean up its act and become more academic and get astronomers to learn more physics before they get their degrees and so forth, because this is going to be the new cutting edge. And some people are more into this than others. In particular, there's a guy named Erwin Finley Freundlich, who's an astronomer who is very interested in what Einstein is doing and begins to study that and try to do so. And a guy by the name of Carl Schwarzschild, who in the year 1909 becomes the director of the Astrophysical Observatory, that institute which I just talked about, those three towers. So in 1911 or so, Einstein comes up with his first version of general relativity. He makes between 1911 and 1915, he had to make a couple of revisions. Okay, if I remember my history of it right. But even the first version started making predictions, and people started getting interested. Well, how do you actually come up with experimental proof? And there were three ways of doing this, and all of them depended on astronomy, which is how the people like Freundlich and Schwarzschild got into this, because they were sort of the astronomers. The first is the perihelion shift rotation of Mercury. This in itself was nothing special. Astronomers had known that since the mid-19th century and had been scratching their heads over this, in fact, since then. So once Einstein's, I believe, even his first theory came out, this all began to fall right in place. So that wasn't a big deal. The second way of doing this was to show that light waves actually were bent by massive bodies, in particular the sun. The people were trying to do that. Freundlich, somewhere there I found a note, a sentence, that Freundlich, who was at first working as an assistant at the Berlin Observatory, which by then I think had been moved to also in the Potsdam area, but had nothing to do with this place here. But then I believe had somehow connected himself with the Telegrafenberg people. He moved over there. Evidently was looking at some old photographic plates, and this was 1910s or something, early 10s. But even he was starting to look in, and I believe the Astrophysical Observatory, in 1940 sent an expedition to Crimea to try to observe a solar eclipse and find, see if the stars had a deviation and moved, only to be caught up with the start of World War I, and then, you know, escorted back through, I guess, neutral Sweden or whatever, back to Germany. So that went down.
Which was lucky,
What?
which was lucky because he was.
Well, I guess they were seen as, I guess in those days, when the war started, people still had a sort of 19th century sort of a cavalier, a cavalier attitude or something.
No, but if they had actually made the measurement there, the theory wasn't quite refined enough, so they wouldn't have gotten as good agreement with the experimental findings.
I'm not sure. Yeah, I mean, from what I understand is they actually never got to do the
They
experiment.
did not get to do it. It was.
What? Yeah.
They did not get to do it.
Yeah, right, exactly. So that went down then. The Astrophysical Institute tried over the next 20 years through into the late 1920s, no less than 6 times to send out expeditions to solar eclipses to find the deviation. The only time they succeeded was in 28, when the said astronomer Freundlich plus other people went to the Dutch East Indies, to the island of Sumatra, and managed to do that and came within 10% or something like this. So it seemed to generally agree with Einstein. The only problem was the Eddington expedition from Great Britain had done that in 1919. And that, of course, so this was just sort of a recapitulation, and that was nice. But basically, the Brits managed to outdo the Germans in this case. All right.
You're going to have to wind it up pretty soon. It's
What?
quarter of.
Well, as long as they're interested, I'm willing to tell you.
Yeah.
As long as people are interested, stick with us if they find us still interesting.
Well, then may be asking a bit of them.
Well, I'm basically asking you if you want to continue this.
No, well, go ahead. I mean, I'm here.
I'm here to.
Okay. So this left the third possibility. And this is, I think, here again, something people don't quite realize. And that is you can prove it by the gravitational redshift. A photon leaving the sun's surface should, in theory, be shifted slightly to the red because the sun is massive. And they started this, and they knew this, even with this Einstein's first theory. And as early as 1913, none less than Carl Schwarzschild was on the top of that, what I showed that the Beamten house, it's called, which is the staff housing, which had the spectrograph, tried to use that spectrograph to get the spectra of the sun to see if he could detect that shift. He couldn't do it because this is a very sensitive effect. But as early as, here again, and this is, I don't think people realize this, as 1913, people were trying to find this. So now we go forward into the mid 2010s. Einstein comes up by 1915 with his general theory, and he and Freundlich, they knew each other, okay? They realized if you're going to, I mean, Schwarzschild for a minute, of course, it's better known, he gets interested, for some reason, he gets this wave of patriotism, and God knows why. So he everybody leaves his academic posts, signs up with the German army, gets sent to the Eastern Front, on the Russian front, being a mathematician, artillery tables. God knows why. When Einstein publishes his final theory, Schwarzschild figures out the so-called Schwarzschild solution, the spherical symmetric solution, and the Schwarzschild radius that went with it, sends letters back to Einstein back in Berlin. Schwarzschild catches some disease there, and promptly dies of it in 1916. Einstein, having his letters, his correspondence, writes that up, forms it into a paper which he delivers to the Prussian Academy of Sciences in Schwarzschild's name. And that is the Schwarzschild solution, which is now, rather well known for the first real solution to Einstein's equations. And it's the thing Schwarzschild is known for. And that's in most sort of histories or where you have a little bit of histories, that's what they mention. They never point out that Schwarzschild was already trying to find this redshift in the early 1910s. Here again, this is what I want to emphasize. If people were going after this third way of looking at it, Einstein and Freundlich realized they needed another way of doing this. It is now 2018, it's not 2018, 1918. World War II is still going on. Einstein is looking for a way to do this third way, and he sends out feelers even then himself to the Prussian government, the culture ministry, which is also in charge of funding schools and research. If he could get some funding for this redshift, maybe some sort of funding to do this redshift experiment. They turn him down, of course, because it's in the middle of World War I. And then I like, forget it. But this was even in 1918, where the last, where Germany is the March, I think, offensive Germany did failed, and by summer of 1918, Germany was holding on for whatever it was able to. So obviously it would collapse for a few years. But even then, Einstein was behind this. He wasn't just sitting in his office just doing theoretical work. He wanted to see about getting research fund, and he was teaming up with Freundlich. Einstein himself was, shall we say, administratively challenged, and he got Freundlich to be the front man in this effort to get some funding and worry about the administrative details, quote unquote, of buildings and any such of a research facility. 1918, in November, of course, Germany finally agrees to an armistice. You have a total collapse. They had basically a coup d'etat. The Social Democrats take over the government. The Kaiser has to abdicate and leaves town, never to return. Somewhere in all this, Einstein in 1919 tries to get, and I've got more here again, I've got some notes on it, tells Freundlich to see if we can't maybe come up with some funding, and tells Freundlich to try to look into this matter and handle the details. They tried to get the Prussian government to actually give some money, but of course it's not much. Freundlich sets up a kind of foundation to get people to sort of donate money and whatever to set up some kind of an observatory. Now remember, this is in Berlin, or hell is going on. The government has to leave town. They're trying to set up a democratic constitution. They don't do this. They move to the boondocks in Weimar, where it's a little bit more peaceful, where they can set up a more democratic constitution. Hence, historians call this the Weimar Republic. In this period into the early 20s, there was at least one or two putsch attempts. The far-right communists, they tried a coup d'etat called the Spartacus Revolt. I think there was a coup from the far right. So, I mean, this is all going on. Inflation by the early 20s starts to pick up. We know when they're doing this, they started out with something like they wanted 300,000 marks. Then we have a typewritten page where the 3 is striked out by hand and a 5 is put in. And then there's another paper where it says 500,000 marks, and then there's someone puts a 1 in front of it, so it's 1,500,000 marks. So this is like 22 or something like this, 21, 22. So things are really going downhill. What they come up with is, but people do make donations, and this is usually a lot of people from German banks. The reason is the US, and especially the Brits and certainly the French, basically are interested also in setting up some funding in some ways of doing some of the research to find this redshift and in general, but they've excluded Germany because in the wake of World War I, they're still very mad at everybody. So Germany is still kind of the odd man out. And the Germans don't exactly sit on the duff doing this. They basically decide to do whatever they can. And they managed to get fundings from German corporations, banks, German, like Zeiss, like the Zeiss Jena people, the optical company, they make Siemens, the electrical company, they all contribute in payments in kind. And in the and by early 1921, they start building the Solar Observatory to set up a spectrograph. Freundlich, as well as Einstein, they knew each other, and they played in a kind of amateur string quartet. That's how they knew each other. Apart from the fact that Freundlich was, of course, interested in the relativity theory. He was one of the early astronomers. One of the people playing in that quartet was just an up-and-coming architect who hadn't really made his name yet, a guy named Erich Mendelssohn. Okay? And Mendelssohn, and Freundlich tells Mendelssohn as early as mid-1919, even before they had the money, start thinking about a building to house the solar observatory. So Mendelssohn, without even getting paid at this point, he starts making drawings, something which, by the way, we all have. So if you're an art historian, this is a great kind of resource. So starting even in 1919, Mendelssohn started coming up with ideas for what the building you see here. By 1920 or so, 21, they start building this. And if I can show you, this was finally completed in 2024. And if I can quickly go off, they're going to have a cut. Let me show you.
You want to get back to this?
Let me yeah, just quickly click through some of these.
Well, you wanted to go across the row. Or what?
Yeah, just quickly click, and then we'll get to one where you can exactly see how this looks like. I had something. Okay, so go to the next one. Okay, just to sort of click through this. Okay, this is a front view. Okay, you can go to the next one. Okay, this is the back view. Go to the next one. The next one. This is another one I got off the web, which is a lot nicer. But okay, stop. If you just blow it up, so this is what I got off the web, and here it very clearly shows you this is a cholestat. This is a solar observatory, and this is the mirrors where they pick up the sun. It's reflected downwards through that hole through an objective and down into the basement. And we can see this better if we go to the next. Yeah, this is they have a glass case there for the tourist, and they have a little model there. You can see some little figurines to give the scale. And if you go to the next one, which is on the other side, okay, see if you can blow this up. This is a very nice, you can kind of see me with my camera reflected in the glass. So here you see the up in the dome, you have the cholestat, the sun if we can do this, can we, if I can,
What do you want?
you can see the world. The sun comes in here, is reflected from the mirror here, up through here, down through our objective, all the way down here to a mirror, which was for 90 degrees, so in the basement, and into a basement room where they've set up the cameras, spectrographs, or whatever. Okay, and this is what you get is in the focal plane. I think you got an image of the sun about 13 centimeters across, and then they had instruments to pick up a little, like a millimeter by millimeter subset of that, which they can then send for a spectrograph if they wanted to specifically look at the spectrogram of different parts of the sun. So this was basically one of the early solar telescopes. The only other, I think, example of this in the world was actually at Mount Wilson, where starting in the early 1910s, they also had a solar telescope. But because of, I guess, the climate in Southern California, they did not need all the covering. Because the interesting thing here is the building you see, okay, there is the front is it's just a staircase to get up to the various levels. In the back to some offices. The basement is covered with a thick layer of earth to keep the temperature even. So here again, people are very cognizant of effects like that. The tower, the whole optical path, if that's where you want to say, is completely separated from the outer building. They are not connected. They have the separate foundation from the building, and there's no direct connection. So this is to minimize vibration, whatever. The tower itself is not made of steel, it's made of wood, because wood dampens better. Okay, so here again, you see this whole issue of vibrations and other effects, which you need to worry about as an experimentalist. You got to keep that, you got to try to minimize that. And people are always worried about this. So here we have a solar telescope. The problem was, okay, and you have to understand the context. When Einstein, when Eddington in 1919 actually showed that the stars bend, Einstein became essentially a scientific rock star. He was in everybody's front. We've got pictures of in Germany sort of magazines, which is on the front cover, and he becomes a sort of celebrity. And in fact, we've got pictures which here, this is him. This is in the early 20s when they were just finishing this, which I can't show where Einstein's on the front cover. So here again, when they were building all this, you have to understand people like Freundlich and other people were in the front, but Einstein was always sort of in the back, keeping an eye on what was going on and sort of pushing things from the back. So the problem is, in the mid 1920s, this was Michelson made. This is a very unique building, and it's one of the first time that people tried to use rebar concrete. This is a kind of which was just then becoming a possibility. Architects did not really know, structure engineers. This was brand new for them, and they really didn't know what they could do with it or not. Okay, so we have here a building which is a kind of a mishmash. A lot of this is bricks here and there, and I don't know which is a funny, it's rebar concrete, and the covering is a kind of stucco which they sprayed on. The problem was the thermal coefficient of all these materials is different, and you start getting problems with thermal expansion and rainwater, and you start getting cracks. So even by the mid 1920s, you had to have major revisions and people had to reduce stuff at the outer surface. So things kind of delayed. And it wasn't until about the late 1920s, 28, 29, that that work on this redshift and solar observation started to get in earnest, okay? The problem was, as they found out, that trying to doing this redshift from the sun, in theory, is one, it's a very sensitive effect and you have to see it too. There's all sorts of other mess going on. Try to disentangle redshift from the gravitation, from the mass of the sun, from, you know, from the prominences, the turbulence, from other effects. There's something called the limb effect, whereby if you look at the limb of the sun, you get a redshift effect. But if you look at the center of the sun, you get actually a blue shift or something. So they had to start, and remember, this was also in the early days of solar physics in the first place. So they were also just learning what the sun, what's going on in the sun. So they spent most of their time doing this, trying to get this, and didn't get very far. And over the next 4 years, they were trying to grapple with all sorts of issues like this. So 4 years later, what year do we have? 1933. At which point, all of this kind of starts getting trouble. When the Nazis took power in March, guess what happens? A lot of these people basically have to leave Germany. Einstein was by that in the United States already. He obviously does not return, and never does. He finds a home at the Princeton Institute, and that's the last he has anything to do with this. Erwin Freundlich was also Jewish, not that he, you know, was observing anything, but that didn't matter much to the Austrians. He also leaves, he thinks he can maybe come back, but this is impossible. He gets a position in Istanbul, the university there, and helps to found some sort of observatory there. Goes to the United Kingdom, specifically, I think Oxford, and then to St. Andrews in Scotland, and helps set up an observatory there, where he stays until after the war. I think he takes on a British citizenship. He does return to Germany in the 1950s, but there to West Germany. And it doesn't have anything more to do with that. I guess he returns as a pensioner and passes away in Wiesbaden, you know, which is on the Rhine near Frankfurt, I think in 1964. But so he's basically out of it. The architect, which is Michelson.
You're gonna have to wind it up pretty soon.
No, let me just finish. Let me finish. The architect, Urban Mendelssohn, who was also obviously Jewish, he also basically has to leave and leaves for first I think Czechoslovakia, and then he left for a few years, and then after that was taken over, he moves to Palestine, which was then the British mandate. He opens up an architecture in Haifa, and I think he's got some work there. During most of the 20s, he becomes a very famous architect during the Weimar years. He has a number of famous exhibitions in Germany. He does department stores and factories, a Jewish what's Friedhof?
Cemetery.
What?
Cemetery.
A cemetery in Königsberg. So he becomes very famous. He has to leave, and in Palestine, in Haifa, I think he does something there too. He's got some stuff he does there and in Jerusalem at that time. He moves in 1940 though to the United States. Does some work there in San Francisco and some houses and something. I think he passes away in the US in 1953. Okay. Also, there's another guy, Richard Neutra, an architect who I think did some of the landscaping, who is now also has to leave. And after the war in the 40s and 50s, he makes a name for himself building modernist houses in the Los Angeles area, which you may or may not have heard of. So all of these guys have to leave. In 1945, the East Germans kind of pick up this, okay, and in the 50s they try to rebuild this, and they try to do this work. I think in 61 or so, they come up with some result saying they get within 10% of what they expect. Of course, by that time it's too late, because in 1960s there is a pound Ripka experiment or something at Harvard, where they use the Mersbauer effect to send a monochromatic gamma ray up a 20 or whatever meter tower, whose frequency shift they can measure, and that proves without a doubt that the gravitational redshift exists to the 1%. I think they eventually get. So that sort of nails the nail in the coffin. So other attempts to do this astronomically, where the peter out of this stuff, and the astronomers stopped working on that, but start using this to measure masses for neutron stars and so forth. So things go off in a different direction. So this, in the meantime, though, this remains a working solar observatory. Over the years, the East Germans, and then after the Wende, where it became West Germany, several times they had to refurbish the building, especially the outer layer, because of these construction issues. But today it's still a working observatory, and people still use it to do some sort of solar research. And a lot of this has been sort of it's under historic protection. They try to maintain them, and to the extent some of these buildings have been repurposed, but we still have a lot of institutes. There's an astrophysical institute. There's a Wegemann Institute for polar research, which is named after the guy who first in the 30s came up with the theory of plate tectonics. There's a geo research center. So it's kind of a research campus with various institutes, and there's an ongoing concern, and also an historical site which anybody can visit. And I think for certain days they have tours and so forth. So, like I said, I don't think most people know of this place and the science and the history that goes with it. And I think you should find it very interesting. And this was what I'm trying to get across here. Okay.